All right, let's look at the homework 3.9, problem number 9. All right, so let's do this ladder problem. All right, so we have a 10-foot long ladder placed against a vertical wall. Right, looks like the picture here. Right, and then the bottom of the ladder slides away at the rate of 0.7 feet per second. So this guy is moving away that way. 0.7 feet per second, right? And how fast in radians is the angle between the ladder and the ground? So here's the angle here. I'm gonna give it a theta there. And the changing at the bottom ladder is 8 feet from the wall. So here, this is 8 at this moment, right? So we can find, let's go ahead and find a y here. So when x is equal to 8, y is going to be using the Pythagorean theorem. So you have square root of 100 square, 10 squared, so 100 minus 8 squared, 64. So that's a square root of 36, right? So that would be 6. So y is actually 6 when x is equal to 8, right? So let's try to set up an equation. So we want to relate x and the theta in this case. Let's see. X is the adjacent and 10 is the hypotenuse. So sine, actually cosine would be the good one to use, right? So we know that the cosine of theta is equal to adjacent, which is x, over hypotenuse is 10. Right? So we got that equation. And then we know that the rate of change of x, so dx over dt is given to be 0.7, which is given here. And the x value is given there, so that's 8 there. Then we want to find the d theta over dt, because we want to know how fast the angle between the ladder and the ground changing, right? So let's do that. So start with the equation, and we need to take the derivative with respect to t. Right, derivative cosine of theta with respect to t is negative sine of theta d theta over dt is equal to derivative of x is dx over dt divided by 10. Right? Since we're interested in d theta over dt, I'm just gonna isolate it by divide through by negative sine of theta. So d theta over dt is, right, so you're going to have dx over dt on top. There's a 10 already. And then you have a negative. I put the negative sign of theta. Right? So we need to find these values here. So d theta over dt is equal to negative. Right, dx over dt is given right here. So 0.7. So we have 0.7. And 10's 10. And then sine of theta. So in order to find sine of theta, so you have a sine of theta is, sine is opposite over hypotenuse. So opposite in this case is y, which is 6. And the hypotenuse is 10. So we can type in, plug in 6 over 10 for sine of theta. Alright, then we can simplify. 10 on top and 10 on the bottom cancel out. And since I want to eliminate the decimal number here, so I'm going to multiply top and bottom by 10. So 0.7 times 10 is going to be 7. 6 times 10 is 60. Right? So it's going to be a negative 7 over 60 radians per second. Right? So let's type it in. Right? We have a negative 7 over 60. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.